In the third part of section 9, we look at optimisation. Optimisation is about either maximising or minimising something. And often in these questions you're asked to construct the function that you're going to maximise or minimise. Remember, we know whether it's a maximum or minimum by looking at the second derivative. Here's an example. A farmer only has 20 metres of fence, but he only needs to fence off 2 sides in his yard, as 2 sides already have walls. We're going to label this first side X because we don't know what it is, and we're going to then construct a problem from this information. So the first part is write an expression for the area. Well, the area is this side here, X, multiplied by this bottom side. So if the length of the whole fence is 20 and the left hand side is X, then the bottom part of the fence must be 20 minus X. And we can multiply this out. Part B, we need to try and maximise this area. So for a maximum, we need the first derivative to be equal to 0. So we differentiate A. Set this equal to 0. And solve for X. So we get X equals 10. In part C, we're asked to find what this maximum area is. We can just put this value of X equals 10 back into the expression we found in part A. We can find that the maximum area is 100 square metres. Here is a typical exam question for you to try. Press pause, and once you've finished doing it, press play again to see the answers. The first part, we just need to differentiate the expression for V to find dv dt. In part B, we need to repeat the process. We need to differentiate this expression again to find d2v over dt squared. Now on to part C. To find the rate of change of the volume of water, because we're talking about rate of change, we're talking about dv dt, the rate of change of v with respect to time. So we need to put t equals 3 into that first derivative. We get the value 12. So the rate of change is 12 meters cubed per second. In part D, we're going to verify a stationary point. A stationary point occurs when the derivative is 0. So if we put t equals 1 into the derivative, we should expect to get 0 out. So if we substitute in, we get the value 0 as expected. So t equals 1 is a stationary point. Now E. We need to find whether this stationary point at t equals 1 is a maximum or a minimum. So we look at the second derivative. If we put t equals 1 into the second derivative, we get a value of minus 2, which is less than 0. So a stationary point at t equals 1 is a maximum. We'll leave you with the key points from this section.